Algebra 1, Day 23. So today we're going to be talking about direct variation. Now, the great thing about this is you totally already know what it is. You just didn't give it a special name. Direct variation is a special name for a linear equation that has a y-intercept of 0, meaning in y equals mx plus b, it has a 0 in place of the b, which means we can also write it as y equals mx, and some people use different letters for the slope, or sometimes called the coefficient of variation for this, okay? So let's go ahead and talk about this for just a split second. Okay, so first thing I would like to say about this is direct variation. Again, let me repeat what I just said. So this means a normal line that has a b value of 0. B equals 0. So that means in y equals mx plus b, it looks like y equals mx plus 0. We can also write that as y equals mx, right? Because we don't have to write the 0. And some other people, I haven't seen this very often, write it as y equals ax or y equals kx. This kx is going to be the one that you see the most often. They call this my coefficient of variation. Now, that's just a fancy way to say the slope of a line that goes through 0, 0. Okay. So, because, go back to the yellow, because my b is equal to 0, that means both my y-intercept and my x-intercept are located at 0, 0. They're exactly the same. The way that you would say that is that it goes through the origin. Okay. So let me show you an example of what this looks like. So I'm going to head over to my calculator and put in y equals. I'm going to put in an equation. Okay, y equals 2x minus 5. Let's take a look at the table. Here I have my x value. Here's my y value, right? So my y-intercept would be -5, and I know that because x is equal to 0. In between each one of these, I'm adding 2, just like my slope. So my y is going up 2 for every 1 that my x is going up. So 2 over 1, 2 up, 1 to the right. So 2 up, 1 to the right. 2 up, 1 to the right. 2 up, 1 to the right. Okay. Now, if you also notice, 6 makes 7, 7 makes 9, 8 makes 11, right? So there's a couple of different variations here, but we understand it pretty good. But let's turn this one into a direct variation, 2x plus 0. Now, I'm writing it like this, even though technically I don't really need the 0, but I'm just writing it like this. You can see it's exactly the same, except we've changed this to a 0. We've moved it up 5 spaces. All of them have a 0 here. Every single direct variation equation has a 0 here. Never will you refer to something as a direct variation if it is not a 0, ever, okay? So let's take a look at this table. So I'm going to look at this. So here, plus 2, plus 2, plus 2, plus 2 for every 1. All right, so it's the same exact thing, except why people call it direct variation is all I have to do is just multiply this number times a factor of coefficient of variation, whatever they call it, and it gives me the y. I don't have to add or subtract anything. No adding or subtracting, okay? So, 1 times 2, 2. 2 times 2, 4. 3 times 2, 6. 4 times 2, 8. 5 times 2, 10. Okay, that is direct variation. Regular line, direct variation, okay? So let's take a look at today's notes. All right. So, first thing, a direct variation is another name for a proportional, and proportional means they just roll together, okay, relationship. Proportional, which I'm going to pause for a second, I'm going to talk about that word. Proportional means even. So, for example, if I said Mr. Carmona has $50,000 and he wants to give a proportional amount to each student, that means every single student should have the same, or every single student should be multiplied by the same. So proportional relationships pass through the origin 0, 0, which means their y-intercept is always 0, 0. And x-intercept is always 0, 0 as well. A direct variation can be written as an equation in the form of y equals kx, where k is my constant of variation. So notice, lots of different names for this. Official name is constant of variation. Same thing as rate of change, same thing as slope. Let me make a note of that. Slope, rate of change, all those formulas, right? All the ones that we learned before, and also my k is part of that. But k only applies to these guys with a p-value of 0, okay? Also known as slope or rate of change. All right, so whenever they say which table represents a direct variation, I'm going to look at this. I see domain, I see range, again domain and range. So I always want to differentiate between them. So I look at this. Can I multiply 0 by anything to get a 2? No, that's not direct variation. Okay, this is times 7, times 6, times some decimals, right? So these are not all the same. This is not direct variation. Let's look at table B. 0 times 0, so I don't know. I can multiply by any number and still get 0. Times 5, times 5, times 5, yes. So table C represents a direct variation, and its constant of variation is 5, because every single one of those was multiplied by 5. All right, so let's look at these two graphs here. And here it says, which one represents a direct variation? All right, so first thing I'm going to do is I'm going to look at x-axis, my domain, and my range y-axis. I'm going to look for that origin, and that line better be going through that origin. That is not a direct variation. This one is, because it goes through the origin. So graph A represents a direct variation, and its constant of variation is, well, I don't know. Let's go back and calculate. So since my x-intercept and my y-intercept are the same, I'm going to instead look for one that goes exactly through the corners, and I found it here at this blue dot. So let's go ahead and count. 1, 2, 2 down, 1, 2, 3, 3 to the right. So negative 2/3. That's my direct variation constant, okay? All right, let's look at the next part. We can solve direct variation word problems by setting up proportions. Now, these proportions are weird, so do not think that this is super confusing. You can do a lot of different ways, okay? Lots and lots of different ways. But what I will tell you before we get started on this, let me go back. I'm going to write this down, okay? So if I have this equation and I wanted to get k by itself to figure out who is k, I see there's nothing adding or subtracting, so all I can do is divide. I'm going to divide both sides by x, and I get this derivation. So my k value is equal to y divided by x, just like slope, okay? So if I do this, whenever they give me a pair, I divide that y by its x that's stuck to it, I get my k. And then any x I have, I can multiply by that number to get the y associated with that one, okay? There's also a way of setting up these relationships, which I really do not like. So I'm going to show you how to do it this way because it's a lot less confusing, okay? All right, so they told me y varies directly with x. Anytime I see that phrase, I automatically know y equals kx. Okay, y equals 10 when x is equal to 4. I need to find y equals 14. What is x? Okay, so first thing, 10 comma 4, and then x comma 14. Okay, so first thing I'm going to do is I'm going to say k equals y over x, which is, let's go ahead and put those in, y over x, 4 over 10, 2 over 5. All right, so now I can multiply any x by 2 over 5 in order to get the associated y value. But how in the world do I go from a y to an x? I do the opposite. I divide. So x is going to be, I'm going to show you how I got there. So y equals kx. Okay. 14 equals 2/5 of something. And how do I get rid of the 2 over 5? I can divide by 2 over 5. I can multiply by its reciprocal, which is the same thing. All right, and I get x is equal to 5 times 7, 35. That's what they were looking for. Okay, now I'm going to show you the other way. Totally don't freak out when you see this because it's ugly and I hate doing it this way. All right, so let me clear up some space here. Oops, hold on. All right, iPad, stop playing with me. Okay, here we go. Okay, so I'm going to start over again. They gave me 10, comma 4, x, comma 14. Now, the other way to do it is to say y over x equals y over x. All right, so I'm going to go to my highlighter. So I'm going to use my colors from my original one here, my x and my y. And for the other ones, I'm going to choose different colors just so we can differentiate among them. Now, you can set it over as x over y, y over x, but I would suggest just doing y over x so that way you'll remember k is equal to y over x, okay? So let's plug these in. 4 over 10 equals 14 over x. Okay, how in the world do I solve this? Well, cross multiply, okay? So let me move this over here so I have just a little bit more space to work. Okay, so I'm going to cross multiply. 4x equals 140. Divide by 4, divide by 4. X equals 35. Same exact answer, two different methods. And I'm showing you them both because some people will totally understand the proportional thing, and other people like me will not like it and need to just work it out in a simpler fashion. Okay? All right. So a storage photo enlargement machine is set up so the length varies directly with the width, right? So they have some kind of multiplier between them. Two current photo sizes are shown. What is the length of the smaller photo? Okay, so this is an X, Y, X, Y. Okay, so I'm going to write out my formula. Okay, and I'm going to use my standard colors for my regular values. And then over here, I'll choose some different colors. All right, let's plug these in. So 5 over 3 equals 3 over x. Cross multiply, divide by my coefficient, and I end up with a fraction, x equals 9 over 5. Okay, that's all you have to do. Do not let yourself be tricked into thinking this is harder. I showed you these two ways because I know that some people are going to understand one better than the other. Most of the time, this is usually the shortest, but setting up this thing is what confuses most people, okay? So I want everybody to go ahead and try